Hey, subscribers!
No.
Patrick, how many subscribers do I have now? 17. Okay. All right. So we are in the last section of chapter 8. Do you know the parallelogram? Do you know the Venn diagram that I showed you guys of all the polygons? And we had, oh man. Well, I guess I could draw it here. Inside the parallelograms, we had rectangles and rhombuses, and the intersection of those were the squares, right? Underneath the parallelograms, okay, were exactly the trapezoids, and we're going to learn those trapezoids today. So you can look back at that. I unfortunately don't have that up here right now, but that's fine. You have it in your packet. And my students have already copied this down, so subscribers, if you're copying this down, just go ahead and press pause. Okay? So trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay? So it's not a parallelogram. So it only has one pair of parallel sides. And make sure you draw the pictures as well. Okay? Basis of a trapezoid are the parallel sides. Okay? So those, when I refer to the bases, we're talking about the parallel sides. The other two sides are the legs. Okay? The trapezoids have two sets of base angles, okay, two pairs. One pair here, one pair here, okay? They're not necessarily congruent, okay, but that's one pair and that's one pair. So that's that. Okay, an isosceles trapezoid, gentlemen, isosceles trapezoid. Make sure you're drawing these pictures. Okay, the legs are congruent. We're going to learn about those in just a minute. The mid-segment of a trapezoid is a segment that connects the midpoints of its legs. So, here's the midpoint of this leg. It's right in the center, cuts it right in half, bisects that leg. So this length is the same measure as this length. Now this side, this leg, is not the same measure as this one. And I drew that specifically. I wanted you to see. Just because this is the midpoint doesn't mean these lengths are the same, okay? But this side has also been bisected, okay? And a kite we'll go over in just a minute when we get to the kites. So let's talk about these theorems first. These are converses of each other, okay? If a trapezoid is isosceles, then a pair of base angles is congruent. Each pair of base angles is congruent, okay? So if we know that a trapezoid, these two triangles right here tell us we have one pair of parallel sides, which makes it a trapezoid. So if the trapezoid is isosceles, that tells us it's an isosceles trapezoid. Then each pair of base angles is congruent. So then we know that pair is congruent, and that pair is congruent. Okay, the converse says, if a trapezoid has a pair of congruent base angles, then we know it's an isosceles trapezoid. Okay, so if we are given just this information here, and we're also given it's a trapezoid. Then we know it's isosceles. Then we know the sides are going to be, these legs here are going to be congruent. Okay? And those are converses of each other. There you go. Okay. If a trapezoid is isosceles, if and only if, okay, that means its if then and its converse are both true. It's an if and only if. Okay. If and only if its diagonals are congruent. So, if you've got a trapezoid where the diagonals are congruent, then you know it's isosceles. Okay, it works both ways. So, there are the diagonals. Okay. Let's apply them. So a shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. Okay. It's a trapezoid, and it's isosceles. Okay. Find the measure of angle N, angle L, and angle M. Okay, so let's start with, we're given these two lines are parallel. I'm going to extend these out so you can see this. Okay? Think of this line here as your transversal. What are those kind of angles called? Consecutive interior. Consecutive interior angles are what when the lines are parallel?
Supplementary.
Supplementary. So, if the measure of this angle is 50 degrees, what does the measure of this angle have to be?
130.
Done. Okay? And now let's look back at the theorems we just learned. We're given an isosceles trapezoid. So what does it tell us about the base angles? If a trapezoid is isosceles, then each pair of base angles is, there you go. So that's got to be 50, and that's got to be 130. Okay, so the measure of angle N is 50. The measure of angle L is 130, and so is M. Questions? Try the next one on your own. It's just the same. Go. I'm wearing my snow necklace, subscribers. We will get snow. I'm feeling it.
Loudoun County cannot go an entire year without can't come.
We didn't have any snow days a few years ago. It was like 2012, I think.
It doesn't exist.
I have to break this.
Okay. So, anyone? What am I doing?
Wait, I can answer.
Sure, Natalie.
Measure of angle C is 135.
Okay.
Measure of angle A is 45. And
Oh my god.
and D is 45.
Good.
Wait, 40?
Any questions on that?
No.
Good?
I'm good, yeah.
Okay. So, I already had you guys copy this down to make our video shorter. So our subscribers didn't have to listen to me talk for like 45 minutes, even though I'm sure that would be, who wouldn't want to listen to me talk, right? Okay, we have already learned this year, okay? We've talked about what a mid-segment is. It's in the middle, and really, if you can average two numbers, you can do this. How do you average two numbers?
You add them up and divide.
You add them up, and then you divide by 2. Good. Okay. So that's where this half is. We're adding the two segments or segment lengths up, and then cutting it in half, dividing by 2. Okay. You have to memorize this formula. It's not on your formula sheet, but it's really pretty simple. So here we've got in the diagram, MN is the mid-segment. Okay. They tell you it's the mid-segment, so you know it's directly in the middle. Okay, this is asking you to find the length of MN. So, it's really just the average of those two numbers. So, go for it. You guys got calculators? You do have to be careful with how you put this in your calculator. If you put it in like this, well, okay? Your calculator is going to do the division first because it knows the order of operations. That's not what you mean. There's a parentheses around that numerator and around that denominator. So two ways you could do this. You could put a parentheses around your 16 plus 9, so you don't have to worry about it. Or Some people put in 16 plus 9 and they press enter. And then divided by 2, press enter. Either way, what do you get?
What's that called?
What do you get?
12.5.
12.5.
6.25.
And when you get an answer, look at it. Is it reasonable? Is that number right in the middle of 9 and 16? Because you know this number needs to be between 9 and 16, right in the center. 12.5 it is. 12.5 what? Are we dealing with units here? Inches. Okay, do the next one. Go. What is it? 21.
The feet.
Moving on. Can I move on? Did you guys get that? Is that too fast?
Wait, no, we're gonna
Secret phrase. Secret phrase. All right. Who's doing secret phrase number 1?
John.
Well, they brought it up today.
Okay. What is the secret phrase number 1?
Peanut butter bok choy.
Bok choy. Okay. Peanut butter. What?
Bok choy.
Peanut butter bok choy is the secret phrase number 1. Peanut butter bok choy.
How can peanut butter be vegetable?
Okay. All right. These are better than I can even come up with. This is fabulous. All right. All right. Let's go back and look at the kite definition. All right. Let's get serious. Kite. It's a quadrilateral that has 2 pairs of consecutive congruent sides. You already have this written down. Okay, but opposite sides are not congruent. In fact, if I remember correctly, these are in your notes in 8.2 and 8.3. Yes, we were talking about tests for parallelograms, and I actually drew in order for your shape to be a parallelogram, you've got to have both pairs of opposite angles congruent. And then we drew this picture. If you had one pair of opposite angles, it could be a kite. That was the first time we had heard about kites. It's not in your notes right now. That's from 2 days ago. Here's a kite. We're going to learn in just a minute. We've got one pair of opposite angles that are congruent. Okay. Here, okay. So, if a quadrilateral is a kite, okay, so we've got one pair of consecutive congruent sides, 2 pairs of consecutive congruent sides. We've got a kite. Then, its diagonals are perpendicular. Done. Okay? If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. One pair. Okay, another thing, that pair of angles is actually in between the sides that are not congruent. It's not really in our curriculum. Okay. Got that? Okay. So, find the measure of angle T in the kite shown at the right. Okay, so we've got 2 angles here. What do we know about these 2 angles? Right, this is clearly a kite. So, what do we know about these angles?
They're going to be congruent.
Those are going to be congruent. Okay, so what do we know also about the sum of the interior angles of a kite, or that shape? Quadrilateral.
Oh, 360.
It is 360. How did you know that?
Because you do 4 minus
You do
2.
4 minus 2 times 180.
Right. You guys probably already have it memorized. But it's the number of sides minus 2
You stole my lightning.
times 180
Fucking thunder.
gives us the sum of all the interior angles. Okay, so we know the sum of those interior angles is 360. Okay, so now what can we do with that information? I'm just going to call this x because they're both the same, but we don't know what they are. So how can we write an equation
70
to represent this?
2x plus 100 equals 360.
plus 2x equals
Okay.
360.
You do 158 plus 2x equals
2x plus, I'm going to write 70 plus 88 equals what?
360.
Very good. All right,
360.
solve for x, go.
Read that.
This was hard for you guys. Like, even 2 months ago. Looking at a diagram and writing an equation, you guys are really good.
101 degrees.
101.
Daniel, I already put that.
Okay, I'm getting, someone said 101, is that
Yeah,
right?
that's
It's
right.
101.
That was Daniel.
Oh my.
That was me.
goodness.
I like how you
it was
guys are
Daniel.
speaking loud enough. Let me just write x
Really
equals
loud.
101.
Don't worry.
The question is asking for the measure of angle t, so I'm going to write the measure of angle t is 101.
Thank you. Tell me something I haven't.
Any questions? Try the next one.
Back on the times.
X equals 10.
X equals 10. Oh, it's X equals 100.
Ha, got you.
Actually, it's the measure of angle G equals 100, Daniel. So,
Jeez, Daniel.
the measure
Can I
of
have
angle
somebody
G
else
equals
do this problem?
100.
What is this? I got this.
Algebra.
Measure of angle G equals
What did you
100
get?
degrees. No, you said 100, not 100 degrees.
100 degrees.
Let's solve for x first.
I already did.
What did you
He
get?
said it.
X equals 100.
X equals 100. Did anyone else get that?
Yeah.
You got 100? You got 100?
Same.
Okay, we're going with 100.
Yeah, because if you add 85 plus 75, it makes 160.
160, 100, another 100. 360. Perfect. All right, so the measure of angle G is,
100 degrees.
thank you. And that's what I got too.
We're good.
Great job.
Are we also going to do
What is this, algebra?
Yes. All right, so please, right now, subscribers, take out your other notes from Chapter 8 on parallelograms and special types of parallelograms. So moving on to 8.6, just kind of a summary of the whole chapter.
You should have made
Why don't you make it a whole separate video?
Wait, do we have to take the other one out?
Oh, yeah.
Together.
Yeah, you should have made this a 2-part video.
Yeah.
2 parts,
Yeah.
It's not.
Because
2
then
different videos.
people look at it and it's shorter, you know?
But then I have to tell them to watch 2 videos. We're going to keep going.
Oh,
I'll
I
think
don't
about
have
it. I'll
that
think
page
about that.
packet.
All right, so, yes.
I don't have that page either.
Seriously?
Yeah.
Because you're not rich. I don't have that page either.
It says polygons review.
Oh, I have it.
You'll be right.
Oh.
I mean, I have it.
That's me.
All right,
Actually,
does anyone have it?
I did.
I have it.
No. You don't need that. You don't need that. Okay, you're gonna mess it up.
hey, you don't even perfect.
They had to copy this for me
One video.
twice. Oh. All right, who doesn't have it?
I don't. We should go home and pack it.
There's one set of notes, they copied it for me twice. One set has it, the other set does not.
I just like get the one thing.
Because I'm
I just want to use it with that. I'll grab one.
Just make sure these have it. Yes.
Remembering.
It's good. It's so gross.
And you guys can strip this page out.
So gross.
Yeah, that's fine. Anybody else? Everybody else has it. Okay, so quadrilateral ABCD has both pairs of opposite sides congruent. What types of quadrilaterals meet this condition? All right, so we've got a parallelogram. Okay, they want this to be a rectangle. What do we need to add to this figure here?
Angles.
Okay.
So smart.
Okay, rhombus.
What? Who said that?
They want this to be a square. What should we add here to the diagram to make it a square?
The angle, the right angle.
Got to have those right angles, otherwise we do not know it's a square. Okay. Quadrilateral JKLM has both pairs of opposite angles congruent. What types of quadrilaterals meet this condition? Both pairs. Both pairs of opposite angles congruent. All right, so if you go back to your 8.2 and 8.3 notes, both pairs of opposite angles. Where are we? Here.
Wait, can you go back? I missed the notes on that page.
Yeah. I'm just trying to show you, these are your notes from 8.2 and 8.3. This is a review, that both pairs of opposite angles are congruent, okay?
Doesn't square have a U?
For parallel. Trying her best. Subscribers, they're making fun of me. Okay, so
Care.
any type of parallelogram will have both pairs of opposite angles congruent. So let's name them. How about just parallelogram? Gotta make sure I spell it right. Otherwise people will make fun of me. Parallelogram, what else? Rhombus. Square. I know, I did it on purpose. I wanted to see if anyone would notice. Just trying to do my video longer.
Just trying to get rid of you.
Rectangle. Almost finished.
Scared.
I'm gonna do the last.
Actually, that's not how supposed to
Yes. All right, so now let's have another secret phrase.
Scared.
Coconut. Okay. Coconut sharks in the water.
That's such a long.
That's the second secret phrase.
It's a reference.
I love it.
Too long.
Okay. What is the most specific name for quadrilateral ABCD? What is, guys, focus please.
Square.
A scare.
A scare.
It looks like a square,
But
but it's not a square.
Rhombus.
Because no one's told us it has, we've got right angles.
Parallelogram.
So
Couldn't it be a, it
Can't
could be a
say
rhombus,
square.
it could be a rhombus.
Quadrilateral.
all the sides are congruent.
Rhombus.
It's a rhombus.
It's a rhombus.
I'm so smart.
Okay. Example 3.
I'm so
Identify a
smart.
quadrilateral.
No one asked.
Is enough, gentlemen, is enough information given in the diagram to show that the quadrilateral FGHJ is an isosceles trapezoid? Okay. So first thing we have to determine is it even a trapezoid?
Yeah.
Okay. So are these two sides parallel? We haven't been told that. But what are these kind of angles called again? Consecutive interior angles are what when the lines are parallel? Are these supplementary? Okay, that means that those two lines are parallel. So how can we show? So we'll do 78 plus 102 adds up to 180. Okay, so we've got a trapezoid. Okay, now, more specifically, is the trapezoid isosceles, okay? We don't want to say a trapezoid is isosceles if it's not. Okay, you might have a quiz or a test where it gives you a trapezoid. It might not be isosceles. Don't write isosceles trapezoid. Okay, so is it isosceles? How are we going to figure out if it's isosceles or not?
Down to 360.
Okay, yes, but it's not going to tell us if these sides are the same length. Take a look at your theorems we learned today.
And if the base curves are
It's the base angles are congruent.
Okay, so if a trapezoid, guys, please, if a trapezoid has a pair of congruent base angles, which it does, right, 102, 102, then it's an isosceles trapezoid. Okay, so okay, 102, 102, isosceles. Is that it?
Oh, we still got 2 more.
One more. 2 more. Jeez. 7 more. Okay. What's this?
Secret phrase.
Oh.
It's not a secret phrase. Shape.
It's a quadrilateral. More specifically, it is a.
Rhombus.
No.
No.
We've got consecutive
Shape.
sides here that are congruent. What's that
Oh,
called?
wait.
Kite.
Kite. Very
So
good.
smart. What'd you say? What do you have in this class? That's what I thought.
Okay. Is there enough information given in this diagram to show that the quadrilateral BCDE is a rectangle?
No. But we don't have the right angles.
Yeah, we do, because
Yes,
90
Oh, yeah, we
plus
do.
90.
Never mind.
It can be done to a bunch of different.
Don't you only need
Yeah,
one
Right
right
angles,
angle?
let's do it.
We have 3 right angles. We don't have this angle here. Is
But it has
that
to add
enough?
up.
Yeah. It's a
The
How?
only way you could add
Because
up.
it has 4 sides, so it has to equal 300. Wait, no.
Yes.
Yes,
It has to be
you're
edited,
right.
but
Oh, yeah,
it has to
360
add up by
degrees.
360.
Okay, so they've got to all add up to 360, right? That's 90, that's 90, that's 90,
This has to be.
270. So subtract that from 360.
So it has to be 90.
That has to be 90. Perfect. Any questions? We're done. Thanks for watching. Don't forget to click like.
Oh, we have like the last one.